Can a harbor for small boats be excavated almost instantly with high explosives? On the island of Hawaii, the U.S. Army Corps of Engineers set out to find out. The site chosen for the experiment was the village of Kawaihae on the northwest tip of the island. At first glance, Kawaihae appears to be a remote, unimproved area. But in early 1959, the Honolulu district of the Corps of Engineers completed a commercial harbor here. It has become a shipping center for a large segment of the island. Sand and gravel from area quarries, molasses from the sugar refinery, and cattle from the island's huge ranches are shipped from here to other Hawaiian islands and the mainland. But there is a serious need for a safe anchorage for small craft at Kawaihae, a need that becomes greater each day as Hawaii's tourist industry grows. In association with the state of Hawaii, the Corps of Engineers Honolulu District has planned a small craft harbor for Kawaihae. Because federal participation in this harbor has been authorized by the Congress, although not yet funded, it was the site chosen for an explosive excavation experiment by the Corps of Engineers Nuclear Cratering Group. The plan was to excavate an entrance channel and a small turning basin. Later, by conventional construction methods, the initial breakwater section would be added to give Kawaihae some degree of small craft protection. But before this point was reached, there was much work to be done. Nearly 6 months before the actual excavation explosions were to be triggered, specialists from the Army Corps of Engineers, other federal agencies, the state of Hawaii, and private industry gathered at the project site for a series of vital calibration tests, relatively small explosions to determine the effects on the area. They needed answers to some key questions. What, for example, would be the effect of the underwater explosions on the sea life? The Hawaii Department of Fish and Game worked side by side with the engineers to make this determination. Overlooking the project site stands an historic heiau of great importance to Hawaiian culture. Experts from the University of Hawaii and the B.P. Bishop Museum in Honolulu, depository of Hawaii's archaeological treasures, worked with the engineers to assure preservation of the historic structures. The detailed study even included marking individual rocks. Just around the cove from the harbor site is the luxurious Mauna Kea Hotel. Would large explosions cause structural damage? What would be the effect on the commercial harbor and its supporting facilities? And what would happen to the homes and businesses at Kawaihae? For the future, what would be the results of seismic shock, overpressure, wave action, and other phenomena here at Kawaihae, which could be used to forecast similar reactions at other spots in the world in the future? Tests held in November of 1969, the holes for explosives were drilled from a causeway pushed out to sea. The holes were charged with aluminized ammonium nitrate slurry, the commercial explosive to be used in the final experiment, and the holes were covered with native material. Then the causeway was removed to leave the charged holes underwater as required for valid test results. The first calibration explosion to be 1 ton of the ammonium nitrate with center of burst 14½ feet below mean lower low water in about 3½ feet of water. Local police were briefed and roadblocks manned both for safety and to keep vehicle noises from disturbing the delicate instrumentation. Interested people gathered early at designated observation points. Last-minute padding was applied to the heiau, and a final security sweep was made of the blast area.
Minutes. Please observe radio silence on this frequency for the remainder of the count until the net is cleared. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Detonation of tugboat phase 1.
As soon as the area had been cleared, soundings were made to establish the results of this 1-ton blast. The profiles were studied avidly. In planning these explosions back at their headquarters in Livermore, California, engineers of the Nuclear Cratering Group had anticipated craters which would be quite deep in relation to their width. Instead, in this first shot at Kawaihae, they got a wide, rather shallow crater. This was the result of using explosives underwater in a soft coral material which crushes easily. There were 4 more explosions in the November calibration series. The final shot in the series was a 10-ton blast, fired 41.5 feet below mean lower low water. This shot was in about 6 feet of water and was the deepest of any of the calibration shots. It was drilled 35.7 feet into the coral. The profile of the crater in the first calibration detonation was characteristic of all found in the November tests, wide, flat excavations. These characteristics made it possible for tugboat planners to revise their design for the final excavation and also to speed up their timetable. The new plan called for 3 series of 4 explosions each, with each hole loaded with 10 tons of the aluminized ammonium nitrate slurry. First to be fired would be the 4 seaward emplacements. 5 days later, the next 4 in the channel would go, and 2 days after that, the 4 charges which would excavate the turning basin. Because of the water depths and distance from the shore, the holes were drilled from a barge. It was not necessary to case the holes to keep them rigid. Instead, the contractor used a collar which rose from the hole opening a few feet above sea level. By keeping this full of water, water pressure held the hole open. Drilling moved rapidly because the material was soft and pulverized easily. The bottom of each hole was 47.6 feet below mean lower low water, and the contract allowed tolerances of only 5/10 in depth. Into the completed hole went a can, 5 feet 1 inch in diameter and 11 feet 3 inches high. The can had been designed to hold 10 tons of the explosives. A fill pipe came from the top of the can to 3 feet above mean lower low water. In diagram, the installation looked like this. Each charge was designed to have a center of burst 42 feet below mean lower low water. Water depths in the project area ranged from 3 to 10 feet. After the cans were emplaced and the holes backfilled, the slurry was pumped in. While the charges were being prepared, work was going on toward even more intensive scientific study than had been carried out in November. Seismic measurements, air overpressure, water pressure, velocity and acceleration, wave propagation and measurements, and structural integrity were all under study. And the local non-engineering interests also came under careful scrutiny. In the November tests, no harm had been done to the historic Heiau, and there had been little damage to life in the sea. The plan called for the first series of 4 blasts to open the seaward 400 feet of the entrance channel. The charges were set 100 feet apart, and studies back at Livermore indicated the resulting channel section would have a width of 120 feet, with a minimum depth of 12 feet. The first tugboat excavation detonations were touched off at 6 minutes past 9 on the morning of April 23, 1970. And at 9:01 on Tuesday, April 28th, the second 4 10-ton charges were detonated.
Our scheduled detonation time this morning is 0900 hours. The detonation will consist of 4 10-ton charges. Ground zeros are designated by the orange targets. Minus 15 seconds. Minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Again, it was a spectacular sight, but the engineers were plunged into deep study because this time only 2 of the charges had gone off. The misfires threw the engineers and technicians into a flurry of thought and action. This was not the deliberate environment of the Nuclear Cratering Group headquarters in Livermore, nor the Honolulu district offices. The planners were faced with immediate problems in the field, in the middle of an experiment, with only the sparse facilities of a thinly populated island from which to draw materials. Divers established beyond question what was already known, that the cans containing charges G and H were still intact. There were 3 possibilities. The explosive in the cans for some reason was not effective. The detonating chain of wire and primacord had somehow been broken in the microseconds before planned detonation, or there was a failure in the booster charges. The engineer in charge of the explosives has more than 25 years' experience in this delicate profession. And he had said,
What we have here requires, say, the energy equivalent of 1/3 of a pound of TNT to initiate it.
But he was quick to agree that to his knowledge, nobody had ever before used this material in this mass. After an anguished period of deep discussion, field tests got underway the morning after the failure. Of course, all 4 tests detonated with satisfying efficiency, and the test group was left with the conviction that the booster charges simply had not been strong enough to deal with the 10-ton masses of slurry. There was no aluminum pipe on the island of Hawaii, nor in Honolulu. But in a building supply store 12 miles away from the job site, the explosives engineer found some aluminum rain spout, and with the help of eager volunteers, it was shaped into a shell 2 inches square and 10 feet long. The shell was carefully packed with composition C, and a length of primacord was fed to it through plastic hose. The new booster charges were 20 pounds of high explosive, which would run down the full depth of the cans of aluminized ammonium nitrate. These field expedients had taken valuable and unplanned time. But on the morning of Friday, May 1st, only 24 hours past the scheduled time, the countdown started for the final 4 shots in the Project Tugboat experiment.
Helicopter, this is CP. Is the ground zero area clear? Over. 10-4. -5, 4, 3, 2, 1.
This detonation was a total success. Trained eyes and ears knew it, and the stop action proved it. 4 distinct peaks showed above the water before they merged into a single tower of geysering water and crushed coral. And the profiles gave final proof that underwater excavation by explosives will work. The 4 10-ton charges had hollowed out a turning basin 300 feet on a side and 15 feet deep. For the collectors of data, Project Tugboat was over. But for the engineers from Livermore and the Honolulu district, there was yet much to be done. 2 cans of explosives still lay underwater. They had to be located, recharged, and detonated before more work could be done. That chore took a week. Then detailed surveys could be made of the excavation results and charges designed which would smooth out the channel where earlier explosives had failed. It was important work, but in a sense anticlimactic. The nuclear cratering group engineers had already proved their point. The last shots were fired just after Thanksgiving, 1970. Work had already started on the breakwater section to provide protection for small craft which soon would anchor here.
I think we can consider from our work here at the present time that explosive excavation certainly would have an application in future small-boat harbor construction. And I think we can find that there'll be many locations and sites that we can consider such.